Hello students, in the previous session we studied about integration by parts. Here I have some interesting remarks to make. It is worth mentioning that integration by parts is not applicable to product of functions in all the cases. For instance, the method does not work for integral square root of x into sin x dx. The reason is that there does not exist any function whose derivative is root x into sin x. Second, observe that while finding the integral of the second function, we did not add any constant of integration. If we write the integral of the second function cos x as sin x plus k, where k is any constant, then integral of x cos x dx is equal to x into sin x plus k minus integral sin x plus k into dx, that is equal to x into sin x plus k minus integral sin x dx minus integral k into dx, that is equal to x into sin x plus k minus cos x minus k x plus c, that again can be simplified as x sin x plus cos x plus c. This shows that adding a constant to the integral of the second function is superfluous. So far as the final result is concerned, while applying the method of integration by parts. Third remark, usually if any function is a power of x or a polynomial in x, then we take it as the first function. However, in cases where other function is inverse trigonometric function or logarithmic function, then we take them as first function. Now, for integrating by parts, while applying the rule of integration by parts, the choice of first function and second function is very important. So, we give the order of preference for a function to be chosen as the first function as first one inverse trigonometric, second logarithmic, third algebraic, fourth trigonometric, fifth exponential. The order can be remembered by the word ilate. It is formed by the first alphabets of these words. Now, let us look into the integral of the type integral e to the power x into f of x plus f dash x into dx is equal to e to the power x into f of x plus c. Let us solve an example to understand this. Find integral e to the power x into tan inverse x plus 1 upon 1 plus x square into dx. Consider f of x is equal to tan inverse x, then f dash x is equal to 1 upon 1 plus x square. Thus, the integrand is of the form e to the power x into f of x plus f dash x. Therefore, integral is equal to e to the power x into tan inverse x plus 1 upon 1 plus x square dx can be simplified as e to the power x tan inverse x plus c. Now, let us have a comparison between differentiation and integration. First, both are operations on functions. Second, both satisfy the property of linearity. Third, as all the functions are not differentiable, similarly all functions are not integrable. Fourth, the derivative of a function when it exists is a unique function. The integral of a function is not so. We can speak of the derivative at a point. We never speak of the integral at a point. We speak of the integral of a function over an interval on which the integral is defined. Sixth, the derivative of a function has a geometrical meaning, namely the slope of the tangent to the corresponding curve at a point. Similarly, the indefinite integral of a function represents geometrically a family of curves placed parallel to each other having parallel tangents at the point of intersection of the curves of the family with the lines orthogonal, that is perpendicular to the axis representing the variable of integration. Seventh, when a polynomial function p is differentiated, the result is a polynomial whose degree is 1 less than the degree of p. When a polynomial function p is integrated, the result is a polynomial whose degree is 1 more than of p. Eighth, the derivative is used for finding some physical quantities like the velocity of a moving particle when the distance traversed at any time t is known. Similarly, the integral is used in calculating the distance traversed when the velocity at time t is known. Differentiation is a process involving limits, so is integration. 10th point, the process of differentiation and integration are inverse of each other. Now, let us study about definite integrals. In the previous sessions, we have studied about the indefinite integral and discussed few methods of finding them, including integrals of some special functions. In this session, we shall study what is called definite integral of a function. The definite integral has a unique value. A definite integral is denoted by integral a to b f of x dx, where a is called the lower limit of the integral and b is called the upper limit of the integral. The definite integral is introduced either as the limit of a sum, or if it has an antiderivative f in the interval a b, then its value is f of b minus f of a. Definite integral as the limit of a sum. Let f be a continuous function defined on closed interval a b. Assume that all the values taken by the function are non-negative. So, the graph of the function is a curve above the x axis. The definite integral a to b f of x into dx is the area bounded by the curve y is equal to f of x. The ordinates x is equal to a, x is equal to b and the x axis. Here look at the graph, this is the y axis and this is the x axis with the curve q s. We have to study about the area between the region P R S Q P. To evaluate this area, consider the region P R S Q P between this curve x axis and x is equal to a and x is equal to b. Divide the interval a b into n equal subintervals denoted by x naught x 1, x 1 x 2, x n minus 1 x n, where x naught is equal to a, x 1 is equal to a plus h, x 2 is equal to a plus 2 h, x n is equal to b, that is equal to a plus n h, or n is equal to b minus a upon h. We note that as n tends to infinity, h tends to 0. Symbolically, limit n tends to infinity S n is equal to area of region P R S Q P, that is equal to integral a to b f of x dx. That is integral a to b f of x dx is equal to limit h tends to 0 h into f of a plus f of a plus h plus f of a plus n minus 1 into h, where h is equal to b minus a upon n as it tends to 0 as n tends to infinity. This expression is known as the definition of definite integral as the limit of sum. Now, let us solve an example. Find integral 0 to 2 x square plus 1 into dx as the limit of a sum. For the solution, by definition, integral a to b f of x dx is equal to b minus a into limit n tends to infinity 1 upon n into f of a plus f of a plus h plus f of a plus n minus 1 into h, where h is equal to b minus a upon n. Here a is equal to 0, b is equal to 2, f of x is equal to x square plus 1 and h is equal to 2 minus 0 upon n, that is equal to 2 upon n. Therefore, integral 0 to 2 x square plus 1 into dx is equal to 2 into limit n tends to infinity into 1 upon n into f of 0 plus f of 2 upon n plus f of 4 upon n and so on, plus f of 2 into n minus 1 upon n. That can be simplified as 2 into limit n tends to infinity 1 upon n into 1 plus 2 square upon n square plus 1 plus 4 square upon n square plus 1 plus so on, plus 2 n minus 2 whole square upon n square plus 1, and we get 2 into limit n tends to infinity 1 upon n into 1 plus 1 till n terms plus 1 upon n square into 2 square plus 4 square and so on, plus 2 n minus 2 whole square, which can be written as 2 into limit n tends to infinity 1 upon n into n plus 2 square upon n square into 1 square plus 2 square and so on, plus n minus 1 whole square is equal to 2 into limit n tends to infinity 1 upon n into n plus 4 upon n square into n minus 1 into n into 2 n minus 1 upon 6. That can be written as 2 into limit n tends to infinity into 1 upon n into n plus 2 upon 3 into n minus 1 into 2 n minus 1 upon n. That can be simplified as 2 into limit n tends to infinity 1 plus 2 upon 3 into 1 minus 1 upon n into 2 minus 1 upon n, which on simplification gives 2 into 1 plus 4 upon 3, and thus we get 2 into 7 upon 3, and on multiplication we get 14 upon 3 as the answer. Here students, I have some problems as home assignment for you. Note down the questions. Question number 1, evaluate 0 to 5 x plus 1 into dx as limit of a sum. Question number 2, evaluate 0 to 4 x plus e to the power 2 x dx as limit of a sum. Question number 3, evaluate 0 to 1 e to the power 2 minus 3 x dx as limit of a sum. So, students, today we had a comparative study of differentiation and integration. We also looked into definite integrals and limit of a sum. In the next session, we shall study about fundamental theorem of integral calculus. Thank you.